Now we're actually going to learn the rules of how to calculate derivatives. And we're going to start with the most basic functions. I already showed you how to find the derivative of a linear function. That was the slope. A type of linear function is the constant function, and I'll talk about that. I don't know why I wrote that. That was weird, random. Okay. Section 1.5. And we're going to be doing rules for finding derivatives. Okay. So we want to find the rule for the constant function. And a constant function, remember, is f of x equal b, all right? What is the slope of a constant function? All right, well, let's say that's b, and it's just a flat horizontal line, right? It's a linear function with slope equal to 0. And I already showed you how to calculate, or what the derivative was of a linear function. So since the derivative of a linear function is its slope, the derivative of the constant function which is a line having 0 slope, the derivative of a constant function is 0. Okay? So that's the first rule. And it doesn't matter what x is. It's 0 everywhere. The derivative is. In fact, the derivative is itself a constant function, right? Here's the original function f, the constant function, the derivative is the x-axis right there. Right. There we go. Pretty simple. All right. The power rule, let's talk about that. So if you have a function f of x equals ax to the nth power, okay, so a is a real number and n is an integer. And we're going to okay, so we have the derivative. The rule is that the derivative for a situation like this is you take your power, which is an integer, multiply it by your a, so it's n times a, and then you subtract 1 from n to be your new power. So it's n minus 1. That's the power rule. So for example, if f of x equals negative 2x cubed, right? Remember we did this, we calculated the derivative for this function in a previous example. Well, let's just apply the power rule, okay? The power rule says we take our exponent, multiply it by negative 2. 3 times negative 2 is negative 6. And then we subtract 1 from 3, and that gives me the derivative being negative 6x squared. Okay? Now, let's go back to that example that I did earlier, right here. Remember, I did all of this work just to get that answer. And if I had just applied the power rule, I would have just in one step gone 3 times negative 2, subtract 1, and get negative 6x squared. So that's my point. We're not going to use that definition anymore. Applying these rules is much simpler and faster. So that's what we're going to do. But the definition is where this rule came from. So, but once we have established it, like we did here with the slope of a linear function is the derivative of a linear function is its slope. Once we establish that rule, we've done it for all linear functions, we can just apply it. We don't have to just go back to the definition every time. Same thing here. Now, I'm not going to be able to prove this to you. That's beyond the level of this course, but we can just accept that as a valid way of calculating the derivative. Okay. Now, the next rule that we're going to use is the sum. Well, actually, two rules. They kind of go hand in hand. The sum and the difference rule. Basically, what this rule says is the derivative of the sum or difference is the sum or difference, respectively, of the derivatives. Okay, so let's say you have two functions, and f of x equals g of x plus h of x. So we're taking two functions, and we want to take the derivative of this. All we have to do is take the derivative of the individual functions and add them together. So that's just g prime of x plus h prime of x. And then similarly, if your function is the difference of two functions and you want to take the derivative, you can take the derivative of each individual function . So that helps if you have various powers on x added or subtracted together like a polynomial. This rule helps us. These three the power rule, the sum rule, and the difference rule together help us find the derivative of a polynomial. So let me show you some examples. So we have, let's say, f of x is equal to 3x to the fourth minus 2x cubed plus 6x squared plus 7x minus 2. Okay, this is a polynomial. It's a collection of powers on x multiplied by constants added and subtracted together, right? That's a polynomial. So if I want to find the derivative of a polynomial, I'm applying the power rule to each term, but the derivative of this whole thing, I can just take the derivative of each term, right? Separately and do it that way. So I'm going to take 4 times 3, 12x, subtract 1, that's 12x cubed. Now going to the next term, I have a difference here, so I'm going to subtract 3 times 2, that's 6. I'm subtracting, so it's minus 6x. Then I subtract 1 from the power 6x squared. Now going to the next term, 2 times 6 is 12x, because I subtract 1, and that gives me 1, which I don't have to write the 1 there. Now, this piece right here is a linear function, 7x minus 2. And remember, the derivative of this is just the slope. And the power rule works here because the power here is 1, right? 1 times 7 is 7. And I subtract 1 from 1, x to the 0. Anything to the 0 power is 1. So this becomes 7 times 1, or just 7. And the derivative of a constant is 0. So this is the derivative of my polynomial.